So in this class, we shall discuss about formal charge, how to calculate the formal charge over of a particular atom in a molecule or an ion or in a radical. So first of all, what is formal charge? Now, if you want to write down the definition, so it may be regarded as the charge. So it may be regarded as the charge, it may be regarded as the charge that an atom, that an atom in a molecule, that an atom in a molecule, ion or radical may possess if all the atoms are considered to have the same electronegativity. This is this is the definition of formal charge. And now this formal charge over an atom, it can be obtained by using a simple formula. Say this formal charge Fc of an atom, this is given by Nv minus Nm. Okay, where Nv, this is the number of electrons, this is the number of electrons in the valence shell of free atom, like the number of electrons in valence shell of free atom, valence shell of free atom. যেমন ধরো ফসফরাস যদি হয়, ফ্রি অ্যাটমে কত হবে? ফ্রি অ্যাটমে 5টা থাকবে। কিংবা ধরো যদি তোমাকে কার্বন বলে, ঠিক আছে, কার্বন ফ্রি অ্যাটম হলে it will be 4. And Nm, this is the number of electrons belonging. Now this Nm, this is actually the number of electrons belonging to the atom in the molecule. So Nm, we can say, if Nm correspond to the number of electrons belonging to that atom in the molecule, so Nm, we can say this is the number of electrons in the unshared pair, that means in the lone pair, that means number of electrons in lone pair, and half the number of electrons in bond pair. So this is the number of electrons in bond pair. So the formal charge, so the net formula of formal charge, this is given by Nv minus Nlp minus half Nbp. So it's like this. This is how we can, by using this formula, we can find out the formal charge. So let us consider some example. Suppose let us start with, say, pH4 plus. So first thing which we should do is we can write down the structure by using VSEPR theory. Okay, so pH4, you know that by using VSEPR theory, this is pH4, and there is a positive charge. Okay, so we need to check the number of electrons present. See, as per the definition of formal charge, so for phosphorus, if you want to find out the formal charge, say the formal charge over phosphorus. Okay, if you want to find out the formal charge over phosphorus in phosphonium ion, so we know that by definition this is NV minus NLP minus half NBP. So NV, this is 5. Number of lone pairs 0. There are no lone pairs of electrons. So half. See, number of bonded electron pair is how many? 8, because there are 4 bonds. So number of bonded electron pairs, it should be 8. So the formal charge over phosphorus will be +1. Okay. So the formal charge over phosphorus is +1. Suppose if you consider another example, NO2 plus nitronium ion, NO2 plus. So we can write the structure like this: NO2. From VCPR theory, we know that the structure is like this. If you remember, using VCPR theory, like this. Suppose let us consider that the charge, you keep the charge outside, NO2 plus. So formal charge over nitrogen. If we want to find out the formal charge over nitrogen, so this will be given by NV. What is NV? 5 outer electrons of nitrogen minus, if you look at this, you know that there is no lone pair. The structure is linear without any lone pair, isn't it? If you remember the structure without any lone pair, so it is 0 minus half into, see there are 4 bonds, so it will be 8 bonded pair of electrons. So once again this is +1. And if you want to find out the formal charge over oxygen, see total number, if you consider this oxygen, any one of the oxygens, so total number of outer electrons, valence electron, it is 6 for oxygen. Now if you look at oxygen, since it is neutral, so there will be 6 electrons. So there are 4 electrons in the lone pair. And how many electrons in the, there are 4 electrons in the lone pair. And how many electrons in the bond pair? For each oxygen, there are 2 bonds. So situation is like this. So this is 0. Formal charge over oxygen is 0. Often we can find out the formal charge without writing the actual structure. That means we know that NO2 is linear without writing the double bonds. We know that it is linear from VSEPR theory, and if we just keep it like this and then balance the electrons, see there is a positive charge. So the positive charge, as we have already understood, it is over nitrogen. So naturally we are keeping it like this. There are 4 electrons, so that there will be a positive charge. So in this case, if we want to find out the formal charge over nitrogen, this is 5 minus number of lone pairs 2 minus half into number of bonded electrons, that is 4. ঠিক আছে? So this is +1. So in this way also we can find out the formal charge over nitrogen without giving double bonds. Okay, but it's better to write down this structure because you know the structure by VSEPR theory. Suppose let us consider another example. Say NO3 minus. NO3 minus, we know that if we want to write down the structure using VSEPR theory, we know that the structure is like this. isn't it? This is NO3 minus. And if we write down the structure without giving double bonds, then each of these oxygen, it contains 7 electrons, isn't it? And each nitrogen, the nitrogen contains 3 electrons. So if you want to calculate the formal charge over this nitrogen, so in this nitrogen, 5 minus number of lone pairs, এখানে কত হচ্ছে দেখো 0, lone pairs নেই, minus half into number of bonded electrons 6, so this will be plus 2. দেখো plus 2 is correct in this case because each of these, they are negatively charged, they contain 7 electrons, and in this case you see there are 3 electrons, so there will be plus 2 charge. So if we do not give the double bonds, we can write it like this. Previously, in our previous example also, we could have done like this also, without giving this pair of electron. এখানে যদি ইলেকট্রন পেয়ার না দিতাম তাহলে আমরা একইভাবে করতে পারতাম। But in this structure, if you want to, this is the formal charge over nitrogen, and if you want to find out the formal charge over oxygen, দেখো in any of the oxygen, it is 6 minus how many lone pairs? Lone pair of electrons 6. How many bonds? 1 bond, so there are 2 bonded electrons, so it is minus 1. So if you write down the structure like this is how we can find out the formal charge. And if we write down this structure, then the formal charge over nitrogen, this is, see, 5 minus half, sorry, 5 minus 0, মানে কোনো lone pair নেই, minus half. Now how many bonds are there? 4 bonds, so there are 8 electrons, so this is plus 1. So if you write down the actual structure, things are much easier. But if you just write down the sigma skeleton like this, then we have to find it out. Suppose let us consider another example. So this was NO3 minus. Let us consider S2O3 2 minus. If we want to find out the formal charges over thiosulfate, you know that this is thiosulfate, where one of the oxygen atom is replaced by sulfur. So we can write this structure also. We can write the structure like this. Both the structures, they are correct. Both the structures have been observed. So if you write down this structure, the formal charge over the terminal sulfur will be different from the one in this structure. তাই না? দেখো তুমি নিজে calculate, you'll be able to calculate by yourself. See, look carefully. For this sulfur in this structure, see, neutral sulfur, so there will be 6 electrons, and anionic sulfur means there will be 7 electrons, 1 extra electron, isn't it? So if you want to find out the formal charge of this sulfur, terminal sulfur, this is given by 6 minus number of lone pairs 4 minus half into number of bond pairs. ঠিক আছে তো? So this is 0. And if you want to find out the formal charge over this terminal sulfur, see, this is 6 minus how many lone pair of electrons? 6. How many bonds? 1 bond, So 2 electrons. So this is -1. And if you want to write down the sigma skeleton only, তুমি যে কোনো ভাবে করতে পারো কিন্তু। If you want to find out the formal charge of thiosulfate, say terminal sulfur and central sulfur, যে কোনো একটা, by writing the sigma skeleton. Suppose let us write down the sigma skeleton only. Therefore, we are writing the sigma skeleton here only. And we know that this is 2 minus. Okay, so let us, from the sigma skeleton, we are not considering any lone pair over central sulfur. So if you look at the terminal sulfur and terminal oxygens, since there is one bond at each of the terminal sulfur and terminal oxygen, so naturally the valence state is not satisfied. So there will be 7 electrons, 1 electron extra. So if you calculate the formal charge over, say, central sulfur, ঠিক আছে? So if you want to calculate the formal charge over this central sulfur first, okay, so for central sulfur, number of valence electron should be 6 minus 0 for number of lone pairs of electrons, and then how many bonds are formed? 4 bonds, so there will be 8 electrons, so the charge should be +2. The formal charge over the central sulfur will be +2, and the formal charge over terminal sulfur, see, there are 6 valence electrons. Number of lone pair of electrons, how many? 6. How many bonds are formed? একটাই bond. একটা bond মানে 2 electrons. So this will be -1. That means each of these, they will have a formal charge of -1, and this will have a formal charge of +2. So if you write down the sigma skeleton like this, let us consider another anion, that is S2O8 2 minus. S2O8 2 minus. This is peroxodisulfate. Peroxodisulfate. Now this is one of the strongest oxidant, very strong oxidant. So it's like this. See, as if there are two sulfates. Okay, as if there are 2 sulfate moieties, and these two, they are linked together via a peroxo bond. There is a peroxo linkage here. That is why peroxodisulfate. Okay, and if you want to write down the actual structure, so it should be like this. The actual structure, so there will be a negatively charged oxygen here and negatively charged oxygen at this side. So this is the actual structure of per disulfate, and from here you can find out the formal charge over any of the atoms, isn't it? Now if we want to write down the sigma skeleton, so if we want to write down the sigma skeleton only in order to find out the formal charge, now at each of these sulfur, central sulfur, there are 4 electrons, and at each of these oxygens, since there is single bond, there will be 7 electrons. That means there will be a negative charge, and the total charge will be 2 minus. So if you want to calculate the formal charge over sulfur, this is 6 number of valence electrons, no lone pair electrons in lone pair, half into number of bonds. See how many bonds are there around this sulfur? There are 4 bonds. That means there will be 8 bonded electron pairs. So it will be +2. Now at each of the central sulfur, দেখো যদি +2 হয়, এখানেও +2, এখানেও +2, তাই +4 হচ্ছে। আর at each of the oxygen, টার্মিনাল অক্সিজেন দেখো -1 হবে, তাহলে নেট চার্জ হচ্ছে -2 হচ্ছে। দেখো if you look at the terminal oxygens, দেখো at each of the terminal oxygens 6 মাইনাস লোন পেয়ারের ইলেকট্রনের সংখ্যা 6 আর বন্ড হচ্ছে একটা, so this is -1. And if you want to find out the formal charge of these peroxo oxygens, so formal charge over the peroxo oxygens, this one peroxo oxygen, so this equals 6 minus half, sorry, 6 minus number of electrons in the lone pair minus half into bond pair. See, there are two bonds, এদিকে একটা এদিকে একটা, so it will be 4. So naturally this will be what? 0. The formal charge will be, there will be no formal charge, 0 হবে formal charge. Okay, so this is how we can calculate the formal charge over any species by using this formula. It's very simple. Let us consider another example. Suppose বলা হলো যে x, sorry, suppose let us consider ClF4 minus, ClF4 minus. So using VCPR theory, you can write down the structure C7 plus 4 plus 1, 12. You know it's octahedral with two lone pairs. So once you know VCPR theory, you will be able to predict the structures. দেখো with two lone pairs এরকম। এবার তোমাকে যদি ফর্মাল চার্জ বার করতে দেয় ওভার ক্লোরিন, ঠিক আছে? So if you want to find out the formal charge over the central chlorine, কিছুই নেই, দেখো it's very simple. কারণ এখানে তো ডাবল বন্ডের ব্যাপার নেই, এখানে আমরা যা কিছু করব মানে ডাবল বন্ড দেওয়ার ব্যাপার নেই, এইভাবেই করছি। So formal charge over chlorine, this equals how many outer electrons? 7. হ্যালোজেনের 7টা ইলেকট্রন থাকে, নাম্বার অফ লোন পেয়ার্স অফ ইলেকট্রনস 4, 4টে বন্ড পড়েছে, তার মানে 8টা বন্ডেড ইলেকট্রন, তাই তো? So -1. So the charge over central chlorine will be -1. Say SCN minus, thiocyanate, SCN minus. So you know that in thiocyanate, the structure is like this. See, you can find out the structure by using VCPR theory. Central যদি আমরা কার্বন দেখি তাহলে 4 for sulfur, terminal sulfur +1 -1 sigma pi, and for this nitrogen +1 sigma and 2 pi bonds are expected, -2 pi bonds and +1 for the negative charge. তাহলে এটা হয়ে যাচ্ছে 4, so it is 4. 4 means the structure should be linear. So if the structure is linear, CS, C, N, isn't it? The structure should be linear. So we can write down the structure like this, double bond দিয়ে দিলাম। Our nitrogen সঙ্গে there should be triple bond, but once we give a double bond here, the valency of carbon is satisfied, isn't it? So for thiocyanate, in this case, you'll find that there will be a negative charge over nitrogen, and this is what we say, this is isothiocyanate. This is isothiocyanate. But if we go by the other way, okay, that means if we give a triple bond over between this C and N bond, then if you look at sulfur, you see there will be 7 electrons and the negative charge is over sulfur here. So this is thiocyanate. Okay, so you can find out the formal charge straight away. The formal charge at sulfur carbon by using Fc. Say if you want to find out the formal charge of sulfur, this sulfur, terminal sulfur, so this equals 6 minus lone pair of electron 6 minus half into 2 bonded electrons. So this is minus 1, like this. So this is very simple. Now the formal charge can be made a bit more quantifiable by combining it with the idea of electronegativity. Okay, so formal charge can be made more realistic if if the idea of electronegativity, if the idea of electronegativity is incorporated. If the idea of electronegativity is incorporated, and this was actually done by this was proposed by Allen and introduced by Lewis and Langmuir. Proposed by Allen লেখো আর কিছু দরকার নেই. Proposed by Allen, and often it is referred to as Lewis-Langmuir formal charge. Okay, so Lewis-Langmuir formal charge. Now this Lewis-Langmuir formal charge, say suppose AB is the molecule, for example. Okay, AB is the molecule, then it's given by this Lewis-Langmuir formal charge over A. So Lewis-Langmuir formal charge over A, this is given by number of valence electrons of A minus number of lone pairs of electron over A, number of lone pair of electrons over A, minus twice into summation of bonds. I'm coming to this. Summation of bonds, chi A, electronegativity of A, divided by chi A plus chi B. So this is the actually number of bonds between A and B. Between A and B. 2 into number of bonds. Bond summation বলতে এখানে number of bonds হচ্ছে। ঠিক আছে তো? তার মানে আমরা এখান থেকে যেটা বলছি, this is how we can find out the formal charge by considering the electronegativity of A, যার formal charge বার করতে চাইছি. The formal charge of A has to be found out. So we have introduced the concept of electronegativity where the electronegativity of A and electronegativity of B has to be taken into consideration. Okay, so let me give an example. Suppose if you look at HF molecule, HF, okay, and suppose if we want to find out the Lewis-Langmuir formal charge over fluorine. So in that case, the electronegativity of fluorine and electronegativity of hydrogen has to be supplied. Okay, so electronegativity of fluorine, this is given to be 4.0, and electronegativity of hydrogen, this is 2.2. এই values গুলো they will it will be supplied. So if you want to calculate the Lewis-Langmuir formal charge, you know that in HF, this is HF, we know this. So in fluorine, if you look at the number of electrons here, there will be 7 outer electrons, and this is how we can write down the structure. So Lewis-Langmuir formal charge over fluorine, this is what? Number of valence electrons over fluorine, which is 7. Number of lone pair of electrons over fluorine, which is 6. 6টা ইলেকট্রন আছে লোন পেয়ারে, minus 2 into number of bonds with hydrogen, সেটা হচ্ছে 1, and chi of fluorine, this is 2.2, divided by, sorry, chi of fluorine is 4.0, very sorry, fluorine is 4.0 divided by 4.0 plus 2.2. Okay, so if you calculate this value comes to minus 0.29. Now this is more meaningful because the entire electron density, normally you see, if we just consider the formal charge, will be what? If we calculate by the previous formula, it will be 0. But in reality it is not 0 because fluorine is more electronegative. এখানে তো আমরা কি বলি, এখানে বলি হচ্ছে এটা ডেল্টা প্লাস বলি, এটাকে ডেল্টা প্লাস বলি, আর এখানে কি বলি, ডেল্টা মাইনাস। নাও এই যে ডেল্টা মাইনাস ভ্যালুটা, this has become a bit more quantifiable. So the formal charge is actually minus 0.29. Similarly, if you are asked to calculate the water molecule, তোমাকে বলা হলো ক্যালকুলেট দ্য লুইস-ল্যাংমুর ফর্মাল চার্জ ওভার অক্সিজেন ইন ওয়াটার, যেখানে তোমাকে কাই ইলেকট্রোনেগেটিভিটি অফ অক্সিজেন দিয়ে দেওয়া হবে। ইলেকট্রোনেগেটিভিটি অক্সিজেন ইজ 3.4, হাইড্রোজেন তো এখানে দেওয়া আছে, ইট ইজ 2.2. নাও ইফ ইউ লুক অ্যাট ওয়াটার মলিকিউল, দেখো ওয়াটার মলিকিউলের ক্ষেত্রে কি হচ্ছে, ওয়াটার মলিকিউল ইজ লাইক দিস. So these are the two lone pairs. So Lewis-Langmuir formal charge over oxygen, this is given by number of outer electrons of oxygen, which is 6, number of lone pairs over oxygen, number of lone pair of electrons over oxygen, which is 4, minus 2 into number of bonds that oxygen form with this hydrogen, সেটা কত, দুটো বন্ড, so this 2 into 2, এখানে তাহলে 3.4 divided by 3.4 plus 2.2. So this value will be minus 0.43 as per my calculation. You can verify it. তার মানে আসলে এই যে ডেল্টা নেগেটিভ যেটা বলছিলাম, this is minus 0.43. It is normally calculate করলে কিন্তু 0 হতো। এখন আমরা বুঝতে পারছি by introducing the concept of electronegativity, it becomes minus 0.43. Another example, let us give another example. Suppose if you are asked to find out the Lewis-Langmuir formal charge over carbon in C2H4, ethylene. So you know that this is ethylene molecule. And we want to find out the Lewis-Langmuir formal charge over this carbon. Now this carbon, it has actually formed two types of bonds, one with hydrogen, দুটো হাইড্রোজেনের সঙ্গে, and the other with carbon. Okay, so we have to consider both these effects. That means দুটো বন্ডটাই আমাকে কিন্তু কনসিডার করতে হবে. So how to proceed? Achha, we need to give you the electronegativity of carbon, it is 2.6. Electronegativity of hydrogen has to be supplied 2.2. So how to calculate? See, so Lewis Langmuir formal charge over carbon, this is given by number of outer electrons over carbon minus number of lone pairs over carbon. See, there are no lone pairs, চারটে ইলেকট্রন এখানে আছে 0, minus 2 into number of bonds, দেখো it forms with hydrogen, সেটা হচ্ছে দুখানা, into electronegativity of carbon 2.6 divided by 2.6 plus 2.2 minus 2 into number of bonds it forms with carbon. তাহলে হাইড্রোজেনের সঙ্গে যেমন দুটো বন্ড পড়েছে, it is also forming 2 bonds with carbon. এই কার্বনের সঙ্গে দুটো বন্ড পড়েছে, তাহলে 2 into 2 bonds with carbon, 2.6 divided by 2.6 plus এখানে পাশের অ্যাটমটা কি আছে, আর একটা কার্বন আছে, তাহলে 2.6 like this. So if you calculate this, it will become minus 0.17. So this is the Lewis Langmuir formal charge over carbon. Now this idea can also be extended it can be combined with the concept of resonance. So I'm giving a problem related to this. So আমরা বললাম এরকম যে calculate the Lewis Langmuir charges over terminal nitrogen and oxygen for the two major canonical forms of N2O. এখানে তোমাকে বলে দিচ্ছে chi of nitrogen হচ্ছে তুমি বলবে 3.0 and chi of oxygen this is 3.4. তার সঙ্গে বলছে assuming that one canonical form actually has twice the contribution with respect to the other. Evaluate the formal charges over terminal nitrogen, formal charges over terminal nitrogen and oxygen in the equivalent structure. তাহলে try to understand the problem properly. এখানে কি বলা হচ্ছে, এখানে বলছে দেখো Lewis Langmuir formal charge বলছে দুটো canonical form of N2O. See, you know that the structure of N2O, this is NNO, it is linear. I think we have discussed this in VCPR theory. So let me tell you once again. Now if it is NNO, NNO, central nitrogen, 5. For terminal nitrogen, sigma pi, and for terminal oxygen, sigma pi. So it is 4. 4 means linear. So if we draw the linear structure, we can draw the structure like this: triple bonded nitrogen. Now once it is triple bond, see, nitrogen, the central nitrogen becomes tetravalent, which is not possible. So naturally we cannot give any more bond. Already 4টে বন্ড নাইট্রোজেন হয়ে গেছে, তাহলে এখানে প্লাস থাকছে, আর এখানে তুমি বুঝতে পারছো there will be a negative charge over this oxygen. So this is one canonical form. Say this is one, and we can draw another canonical form. তাই তো? সেই canonical formটা কিরকম হচ্ছে? এই লোন পেয়ারটা এখানে আসছে আর এটা এখানে আসছে। We can draw another form. So these are the two major canonical forms. তাই তো? So these are the two major canonical forms. If you count the electrons, দেখো নাইট্রোজেনের 6টা হয়ে যাচ্ছে, that is why there is a negative charge. সেন্ট্রাল নাইট্রোজেনে যেরকম 4টে ছিল 4টেই আছে, এই নাইট্রোজেনে দেখো ইনিশিয়ালি 5টা ছিল, নিউট্রাল ছিল, আর এইদিকে দেখো টার্মিনাল অক্সিজেনে 6টাই আছে নিউট্রাল. So this is the structure 2. So if you want to calculate the Lewis-Langmuir charge for the terminal nitrogen, Lewis-Langmuir charge for the terminal nitrogen in structure 1. Okay, so how to calculate it? Say in, আচ্ছা আমরা এইভাবে লিখি, Lewis-Langmuir nitrogen, terminal nitrogen in structure 1. This is actually given by number of valence electrons over nitrogen, it has to be 5. Then number of lone pair of electrons over nitrogen. Let us check the number of electrons in the lone pair. How many? 2টো ইলেকট্রন আছে এখানে, তাই তো? So it should be 2 minus twice into number of bonds. দেখো number of bonds, এই যে terminal nitrogen, this terminal nitrogen is forming 3 bonds with this central nitrogen. তাহলে আমরা 2 into 3 বলবো, into electronegativity of nitrogen, this is 3.0, divided by 3.0 plus 3.0 হবে, because the atom to which the terminal nitrogen is bonded, it also has electronegativity 3.0 because it is nitrogen. তাহলে এখানে দেখো তুমি দেখতে পাচ্ছ যে, so this will be equal to 0. So Lewis-Langmuir with the terminal oxygen in structure 1, number of valence electron over oxygen, it has to be 6. Number of electrons in the lone pair, let us check. See, number of electrons in this lone pair, in this oxygen, look carefully. The number of lone pairs in this oxygen, it is 6, isn't it? So it is 6 minus 2 into number of bonds. See how many bonds are there? Only one bond is there, isn't it? And that bond is with the central nitrogen. So 2 into 1, 3.0, this is 3.4. Electronegativity of oxygen is 3.4 divided by 3.4 plus 3.0. So if you calculate this, it will come to minus 1.06. Now এখানে minus actual value becomes minus 1.06. if we consider the effect of electronegativity. Okay, so if you calculate the Lewis-Langmuir charge, if you consider the effects of electronegativity, then for structure 2, Lewis-Langmuir for terminal nitrogen in structure 2, এবং nitrogen electron, valence electron will be 5 minus how many electrons in the lone pair? Look at structure 2 and look at the terminal nitrogen in structure 2. This one. So how many electrons in the lone pair? 4. Total 4 electrons in lone pair. And it is forming how many bonds? It is forming 2 bonds. Look carefully, it is forming 2 bonds with adjacent. It is forming 2 bonds with adjacent central nitrogen. So minus 2 into 2 because it is forming 2 bonds. So 3.0 divided by 3.0 plus 3.0. So this value, as per my calculation, it is minus 1. And Lewis-Langmuir formal charge over the terminal oxygen in the second structure. Number of valence electron, it will be 6. Number of electrons in the lone pair. So look at this structure, second structure, and if you calculate the number of electrons in the lone pair, see, look at this structure. How many electrons? 4 electrons in the lone pair. So there will be 4 electrons in the lone pair, and it is forming how many bonds? It is forming 2 bonds with central nitrogen. So number of electrons in the lone pair 4. It is forming 2 bonds with central nitrogen. So this is 3.4 for electronegativity oxygen, 3.4 plus 3.0. So this value comes to minus 0.12. So this is for structure 1 and this is for structure 2. Now, as mentioned, one structure will have double the contribution as the other. Right? So which among these two structures do you think that it will have higher contribution? Among these two, which one do you think should have higher contribution? See, number of bonds, covalent bonds are same. So we have to check which atom the more electronegative atom, ঠিক আছে, the more electronegative atom, oxygen. In this case, the more electronegative atom oxygen contains the negative charge, and in this case nitrogen contains the negative charge. Right? So structure 1, we can say the structure 1 will have greater contribution than structure 2. Since more electronegative atom oxygen contains the negative charge, structure 1 will have greater contribution than structure 2. Right? So twice the contribution. So if we want to calculate the actual formal charge of the equivalent structure, see, the equivalent structure means NNO, and it's like this. So we have to calculate the structure. This structure will have twice contribution, and this will have 2:1 আছে আমরা দেখতে পাচ্ছি. So in order to calculate the formal charge over terminal nitrogen, আমরা কি করতে পারি দেখো? Then what we should do is see, so Lewis-Langmuir terminal nitrogen over the equivalent structure. This will be twice into 0, twice the formal charge of this, plus 1 into formal charge over this, divided by 2 plus 1, divided by 2 plus 1, মানে একটা অ্যাভারেজ ভ্যালু করছি, মানে এটার যেহেতু টুয়াইস কন্ট্রিবিউশন আছে তাহলে 2 ইন্টু 0 ধরলাম, এটার যেহেতু কন্ট্রিবিউশন 1 তাহলে 1 ইন্টু মাইনাস 1 ধরলাম, divided by contribution যেটা আছে 2 plus 1. So this value is minus 0.33, and Lewis Langmuir over terminal oxygen in the equivalent structure 2 into, দেখো এইটা ডাবল কন্ট্রিবিউশন আছে, minus 1.06 plus 1 into minus 0.12 divided by 2 plus 1. So this value is minus 0.75. So this this is how we can calculate the formal charge in the equivalent structure. So suppose এখানে লুইস ল্যাংমুর যদি না দিত, ঠিক আছে, suppose if you are asked to find out the formal charge, instead of supplying if the electronegative values were not supplied, suppose in this question let us assume that the electronegativity value is not supplied, ঠিক আছে, এইটা যদি সাপ্লাই না করতে তাহলে তুমি কি করতে, from these two structures you could have calculated the formal charge by using the previous formula, তাই তো, তার মানে এইখানে ফর্মাল চার্জ এরকম লুইস ল্যাংমুরের বদলে এমনি ফর্মুলা ইউজ করতাম, করে বার করতাম, then the formal charge of the equivalent structure can be calculated by using this idea. Okay, so we have completed our discussion on formal charge.